Greetings aspirants. Hope you all are doing well. The Aditya L1 spacecraft escaped the sphere of Earth's influence on its way to the Sun-Earth Lagrange point L1 as of 30th September 2023. A trajectory correction maneuver (TCM) was performed on October 6, 2023 for about 16 seconds. Why do you think this was needed? See, this was needed to ensure that the spacecraft is on its intended path towards the halo orbit insertion around the L1 point. So, in this respect, we will try to understand what is the mission about, its components, major objectives, and then we'll try to understand the concept of Lagrange points. Before all that, first let us understand the atmosphere of the Sun. The Sun's atmosphere is made up of several layers, mainly the photosphere, the chromosphere, and the corona. It's in these outer layers that the Sun's energy, which has bubbled up from the Sun's interior layers over the course of a million years and is detected as sunlight. So, if we talk about the photosphere first, it is the lowest layer of the Sun's atmosphere and the innermost layer which can be observed directly. The term photosphere means sphere of light and is the layer where most of the Sun's energy is emitted. It takes about 8 minutes for the sunlight from the photosphere to reach Earth. The temperature of this photosphere ranges from 11,000 degrees Fahrenheit at the bottom to 7,460 degrees Fahrenheit at the top. The photosphere is significantly cooler than the temperatures at the Sun's core, which can reach about 27 million Fahrenheit. Its thickness is about 500 kilometers. See, this photosphere is marked by bright, bubbling granules of plasma and darker, cooler sunspots, which emerge when the Sun's magnetic field breaks through the surface. Sunspots appear to move across the Sun's disk. This has helped us to realize that the Sun rotates on its axis. Since the Sun is a ball of gas with no solid form, different regions rotate at different rates. The Sun's equatorial regions rotate in about 24 days, while the polar regions take more than 30 days to complete a rotation. The photosphere is also the source of solar flares. Now, what are these solar flares? These are the tongues of fire that extend hundreds of thousands of miles above the Sun's surface. Solar flares produce bursts of X-rays, ultraviolet radiation, electromagnetic radiation, and radio waves. Then, the layer above the photosphere is the chromosphere. This chromosphere emits a reddish glow as superheated hydrogen burns off. But the red rim can only be seen during a total solar eclipse. At other times, light from the chromosphere is usually too weak to be seen against the brighter photosphere. The chromosphere may also play a role in conducting heat from the interior of the Sun to its outermost layer, the corona. We can see certain kinds of solar seismic waves channeling upwards into the lower atmosphere called the chromosphere and from there into the corona. The third layer of the Sun's atmosphere is the corona. Like the chromosphere, the Sun's corona can only be seen during a total solar eclipse. It appears as white streamers or plumes of ionized gas that flow outward into the space. The temperatures in the Sun's corona can get as high as 3.5 million degrees Fahrenheit, and as the gases cool, they become the solar wind. So, now what is this mission Aditya L1? See, Aditya L1 shall be the first space-based Indian mission to study the Sun. The spacecraft shall be placed in a halo orbit around the Lagrange point L1 of the Earth-Sun system, which is about 1.5 million kilometers from the Earth. Now, if we look at the scientific objectives of this mission, firstly, Aditya L1 is designed to observe the Sun and its dynamics closely. Hence, it will provide valuable data on various aspects of the Sun, including its surface, corona, and the solar wind. Then, it aims to address the question that the high temperature of the solar corona, which is much hotter than the Sun's surface, and scientists want to better understand the reasons behind this temperature disparity. Thirdly, Aditya L1 serves as a space weather station because it monitors and collects data on space weather conditions near the Earth. This information is crucial for understanding how solar variability impacts the Earth's climate and space weather, which can affect communication systems, power grids, and satellite operations. Then, the mission aims to monitor solar activity such as sunspots and solar flares, which can have a significant impact on space weather and Earth's climate. Also, Aditya L1 will help scientists study coronal mass ejections, in short called the CMEs, which are massive eruptions of solar material and magnetic fields. Understanding these CMEs is essential for predicting and preparing for potential space weather events. Then, Aditya L1 features advanced instruments like the visible emission line coronagraph that can observe the inner part of solar corona, allowing scientists to gain insights into mechanisms driving CMEs. Then, by constantly monitoring space weather parameters and collecting the data, Aditya L1 contributes to improving space weather prediction models. This is important for protecting satellites and infrastructure in space. So, as we have talked earlier, Aditya L1 is going to be placed at the Lagrange point 1 or the L1. In this respect, we will try to understand what Lagrange points are. See, Lagrange points are unique locations in space where the gravitational forces between two celestial bodies cancel each other out, allowing a third and smaller body to remain stationary relative to them. These points were named after the Italian and French mathematician Joseph Louis Lagrange. There are 5 Lagrange points labeled, which are L1, L2, L3, L4 and L5. Know that L1, L2 and L3 are unstable while L4 and L5 are stable. See, Lagrange points are valuable for space exploration and satellite positioning because they provide stable positions in space. Lagrange points have been instrumental in planning space missions such as Aditya L1 solar mission by ISRO and several NASA missions. Overall, Lagrange points play a crucial role in space science, satellite positioning, and future space exploration endeavors. They provide stable parking spots in space, enabling a wide range of scientific observations and space missions. So, a satellite placed in the halo orbit around the L1 point has the major advantage of continuously viewing the sun without any occultation or eclipses. This will provide a greater advantage of observing the solar activities and its effect on space weather in real time. The spacecraft carries 7 payloads to observe the photosphere, chromosphere, and the outermost layer of the sun using electromagnetic and particle and magnetic field detectors. The suits of L1 payloads are expected to provide the most crucial information to understand the problem of coronal heating, coronal mass ejection, pre-flare and flare activities and their characteristics, dynamics of space weather, propagation of particle and fields, etc. There are a total of 7 payloads on board, with 4 of them carrying out remote sensing of the sun and 3 of them carrying in situ observation. In summary, we can say that Aditya L1 is focused on solar observation, observing the sun's corona, monitoring space weather, and providing critical data for understanding the sun's influence on Earth's climate and space environment. It aims to unravel the mystery of the sun while helping predict and mitigate the impacts of space weather events on Earth and in space. So, we have discussed all we need to know about the Aditya L1 mission. We'll be back again with another topic. Thank you.